In this question, we have to determine the RMS value of current. Okay, we have two sources here. One is a DC source of 10 volts and an AC source of 20 sin 10t. Now, in order to determine the current across the 5 ohms resistor, we have to use superposition principle. So, this has to be done every time when we have two sources having different frequencies. Okay. Now, first we will find out what is the current with the 10 volts source. Okay, now with only the 10 volts source, okay, which means we are not having this AC source. If you see, we have a resistor, a capacitor. Now this capacitor in steady state will act as open circuit. As a result of which, the current through this branch will be zero. Okay, so there will be current only through this branch. Okay, now that too, this inductor will act as short circuit, as a result of which this 10 volt source will only see a resistance of 5 ohms. So the current I due to this 10 volt source will be equal to IDC will be equal to 10 by 5, that is equal to 2 amps. Okay, now we have to determine what is the current through that 5 ohms resistor in the presence of only the AC source, which is 20 sin 10t. So in this case, what we will do, we will replace this 10 volts source with a short circuit. Okay, now this is to be considered as a short circuit. Okay, now what we will do, we will determine, let me denote this to be at a potential of V. Now we will determine what is this voltage, and from that we can determine what is the current through the 5 ohms resistor in the presence of only the AC source. Okay, to this I will write down the equation using nodal analysis. Okay, so it is V by 5, that is this current. V by 5 plus V by j omega L. This is L is 2, so J, what is omega? It is 10 into 2, so it is 20J plus V minus this voltage, V minus 20 by root 2. Okay, why? Because we are determining the RMS current, so I will take the RMS value of this voltage source, which is 20 by root 2 divided by the impedance of this branch, which is 5 minus J 0.02. Okay, that is equal to 0. Okay, all the currents, sum of all the currents leaving this node is equal to 0. Okay, now we have to solve for this, which when we do, we will get V is equal to 7.018, an angle of 7.24 degrees. Okay, now and hence the current through the 5 ohms resistor. Okay, now we have to determine the current through the 5 ohms resistor in the presence of this AC source. It's very simple. It is this we have determined this voltage V, that divided by 5 will give us this current. So that is equal to 7.018 divided by 5 equal to 1.4 amps. Okay, now we have to determine what is the effective RMS current in the presence of both the DC and AC source. So therefore I is equal to root of 2 square plus 1.4 square. Okay, so that is equal to 2.44 amps. So the RMS current through the 5 ohms resistor in the presence of both this 10 volts DC source and 20 sin 10t AC source is equal to 2.44 amps.